Bismillahirrahmanirrahim. How are you, students? I am your teacher Aftab Alam, and today we will start unit number 3 on page number 55, lecture number 1, subject physics. It is the first lecture after midterm, and the today chapter is dynamics. Before that, we studied kinematics. We deals or we studied in changes in motion only without reference to force, and in dynamics study of motion and cause. So in kinematics we have studied the changes in motion only. Now the dynamics can be defined as the branch of mechanics that deals with the study of motion of an object, and the cause of its motion is called dynamics. So dynamics deals with the study of motion and the cause which produce the motion. And in kinematics we study the motion only. First we will define force. Force, anything which produce acceleration, anything which produces acceleration. Anything which produces acceleration is called force. A force is a push or pull upon an object resulting from the object interaction with another object. Whenever there is an interaction between two objects, there is a force upon each of the object. When the interaction ceases, the two objects no longer experience the force. Force only exists as a result of interaction. So, a force is a push or pull. If you push something, if you pull something, it is called force. It is pushing, and this one is pulling. Full push. This is push, and he is pulling. So, force can be defined as an agent which changes or tends to change the state of an object. The state of an object. If it bring the body from state of rest to state of motion, from rest into motion, or from motion to rest, is called force. So anything which produce acceleration is called force. Anything which push or pull is called force. Changes the state of an object. Bring a body from rest into motion and from motion into rest is called force. Now, next topic is inertia, a property of matter by which it continues in its existing state of rest or uniform motion in a straight line unless state is changed by an external force. The power is required to overcome friction and the inertia of the moving parts. So basically, inertia is the property of material object. Property of material object due to which it opposes change of state, opposes change of state. So if a body opposes change of state, opposes change of state, is called inertia. If you push this yellowish cardboard, the coin will fall in the glass. The coin is in state of rest. When you push, it will this hard surface will comes in state of motion, and coin will try to continue its state of rest. So there is no horizontal support. This support which provide the vertical force, so it will fall down. It will try to continue its state of motion. The tendency preserves in its state of motion. Here will try to continue its state of rest. Here it will try to continue state of motion. Here, when if you place a block here in its path, it will this will comes in state of rest, and the ball will try to continue its state of motion, due to which it fall out, and the coin will fall in the glass. Definition of inertia: the tendency of an object to stay at rest or preserve its state of motion if no external force acts on the system. If no external force is applied. In the absence of an external force, a body in state of rest will remain in state of rest, and a body in state of motion will try to continue its state of motion. If you switch up the engine of a car, after covering some distance, it will comes in state of rest, because there is opposing force, which is force of friction, which is force of friction. Now going to next page, momentum. Momentum is the property in Newtonian mechanics. Linear momentum, translational momentum, simply momentum is the product of mass and velocity. Momentum is represented by P and is equal to mv, product of mass and velocity. V represents velocity and F represents mass, and P is momentum. So P, arrow over it, mass is a scalar quantity and velocity is a vector quantity. So the product of mass and velocity is called momentum. It is a vector quantity possessing a magnitude and a direction. SI unit is kilogram meter per second. Mass is kilogram meter per second. This is the unit of velocity, this is the unit of mass. So collectively it will give you the unit of momentum. And in a CGS system, it is slug foot per second. Now this is P momentum, M mass, and V velocity. Now momentum is that property of material object which increase with increase in mass and increase with increase in velocity. So if you increase the velocity, if you increase the velocity, if you increase mass, if you increase both, momentum will increase. If you keep the velocity constant and you increase the mass, momentum increase. So momentum is the property which increase with increase in mass as well as velocity, and decrease with decrease in mass as well as velocity. Now if you can see in the given diagram, mass is 15 kg, mass is 15 kg. In third example, mass is equal, mass is equal. Here velocity is 0, so momentum is 0. Here 15 kilogram 10 meter per second, so 150 Newton second. Newton second is also the unit of momentum. Newton second is the unit of momentum. It is equivalency. of the unit of momentum. Here velocity is greater. So 15 multiplied by 20, we will get 300 Newton second. So here the velocity is greater. So greater is the velocity, greater will be the momentum. Momentum is that property from which we can say that how difficult or easier it is to stop a moving vehicle, or how difficult or easy it is to bring a moving body in state of rest. If you push a cycle, you can push, because mass of cycle is lesser, so it have less momentum. If you push a train, you cannot push a train, because mass is greater, so greater will be the inertia. So comes towards next page. Momentum is that property which increase with increase in mass as well as velocity, and decrease with decrease in mass as well as velocity. Greater is the momentum, difficult it will be to stop a moving vehicle. Now Newton's first law. If a body is at rest, it will remain at rest, and if it is moving with a constant speed, it will try to continue its uniform motion until and unless acted upon by an unbalanced force. If no force is applied or act on a body, its acceleration will be equal to 0. Force is equal to ma, and ma is equal to 0. If force is 0, ma divided by m is equal to 0, means acceleration is 0. So if a body is at rest or moving at constant speed in a straight line, it will remain at rest or keep moving in straight line at constant speed unless it is acted upon by an unbalanced force. Unbalanced force means if you didn't apply force on an object, it will try to continue its state of motion. And if force is acting on the body will try to continue its state of rest. So if force is acting on a body, the body will be not in rest. It will produce acceleration. If force is applied, if there is no force on the system, a body in rest will remain in rest, and a body in state of motion will remain in state of motion. Book lying on a table, it will remain in state of rest, because if no external force act on the system. But if you exert force, it will change the state. Now an object will not change its motion unless acted upon by an unbalanced force. If it is at rest, it will stay at rest. If it is in motion, it will remain in state of motion. Objects with greater mass have more inertia, and inertia is a measure of mass of an object. Measure of the mass of an object. Greater is the mass, greater will be the inertia. It needs more force, it needs less force. Greater is the mass, greater will be the inertia. Newton's first law is also called law of inertia. Will this ball will move? The answer is no. Why? Because no force is acting on the ball. So if no force is acting, it will not change its state. Not change the state. Not will not change the state of will not change the state. Now Newton's first law example. An object at rest will remain at rest unless acted upon by an unbalanced force. Here you exert force, so it comes in state of motion. An object in motion will continue its constant speed and direction. It will continue motion if no external force causes it to stop, unless acted upon by an unbalanced force. Then it exerts force and will stop the ball. Air resistance is also responsible for bringing the ball in state of motion. With no outside force, a stationary object will not move. It will not move. With no outside forces, a moving object will not stop. It will continue its state of motion if force of friction is zero. Now Newton's second law. Second law states that force of a hand accelerate the brake. Twice as much force produces twice as much acceleration. Here force is applied, so acceleration is produced. Force is double, acceleration will increase. Twice the force and twice the mass gives the same acceleration. Here mass is increased, so it to produce the same acceleration we need more force. So the acceleration produced by a net force on an object is directly proportional to the net force, is in the same direction as the net force, and is inversely proportional to the mass of an object. So if a force is acting on a body, it will produce acceleration which is directly proportional to the force. Greater is the force, more will be the acceleration. Acceleration is inversely proportional to the mass of an object. If, if you push a cycle, you can produce acceleration. If you push a cycle with a greater force, greater acceleration will be produced. If you push a train, less acceleration will be produced because you increase the force, the mass. So mass is increased, acceleration will decrease. If you apply more force on an object, it will accelerate at higher rate. More force, more acceleration. More force, force produce acceleration. Force is increased, acceleration will increase, more acceleration. Now according to Newton's second law, acceleration is directly proportional to the force and inversely proportional to the mass of an object. Newton's second law, the acceleration of an object is inversely proportional to the mass and of the object and directly proportional to the force. Acceleration is inversely proportional to directly proportional to the force and inversely proportional to the mass of an object. Here it is a triangle and it gives the relation between force, mass and acceleration. Unit of force. Acceleration have meter per second square, mass is kilogram, Newton is equal to this, kilogram meter per second square. Now Newton is the force needed to accelerate 1 kilogram of mass at 1 meter per second square. I will define again in a different way. I will search a blank page. This is here I will explain. F is equal to ma. The unit of acceleration is meter per second square. The unit of mass is kilogram. Now the unit of force is Newton, so in place of force I will write Newton. Mass, in place of mass I will write kilogram and meter per second square. So 1 Newton is equal to 1 kilogram meter per second square. I will erase again. Now F is equal to ma. 1 Newton is equal to 1 kilogram 1 meter per second square. The force is said to be 1 Newton. If it produces an acceleration of 1 meter per second square in a body of mass 1 kilogram. If mass of the body is 1 kilogram and force is applied and it produces an acceleration of 1 meter per second square, then the force is said to be 1 Newton. Again, if mass of the body is 1 kilogram and it produces an acceleration of 1 meter per second square, then the force is said to be 1 Newton. Now going back to the page, force is said to be 1 Newton if it acts on a body of mass 1 kilogram and produce an acceleration of 1 meter per second square. Now so first we studied inertia, force, anything which produce acceleration. Force is push or pull up an object. Then we studied inertia. Inertia is the property of material object which produce an acceleration of 1 meter per second square in a body of mass 1 kilogram. Or any inertia is that property due to which it opposes the change of state. Opposes change of state. After that we studied Newton's first law. Then we studied momentum. Momentum is that property due to which it opposes, from which we can say that how difficult or easier it is to stop a moving vehicle, or difficult or easier it is to stop a moving vehicle, or bring a body in state of rest to change the state of an object. If a body is rest, you can change the state of that body by exerting force, which gives which we if you push a cycle, or if you want to stop a cycle, it is easier because less will be the momentum. But if you push a train, it is difficult, or to stop a train it is difficult because momentum is greater. Now then we studied Newton's first law. Newton's first law is also called law of inertia. Newton's first law states that a body in rest will remain in rest, and a body in motion will continue its motion if no external force acts on the system. Then we studied Newton's second law, which states that acceleration is directly proportional to the force. Greater is the force, greater will be the acceleration. Less is the force, less will be the acceleration. And inversely proportional to the mass of an object. And mathematically we can write F is equal to ma. Now this is this is the first lecture after midterm, and after midterm this is the first lecture, and tomorrow we will start mass. We will study mass and weight, difference between mass and weight. The home assignment for you people is, if home assignment is, give two example of first law, give or write and explain two example of Newton first law. Newton first law. Next home assignment it, what conclusion can be drawn from Newton's first law. So write the conclusion drawn from Newton's first law. If you write your answer with you, and in next lecture I will explain conclusion drawn from Newton's first law. Thank you students. Allah Hafiz.